Welcome back, everyone. Ready for another deep dive. Today, we're tackling hash tables. They're kind of the backbone of how a lot of things work online. But, it's wild?
What's that?
The basic ideas behind them, they go way, way back. Like centuries-old math concepts. Surprising, right?
Yeah, it really is. That idea of organizing and finding info fast, especially when you've got tons of it, mathematicians have been hooked on that for ages.
Okay, so picture this. You're running the Library of Congress, right? Millions and millions of books. How do you find anything quickly?
Oh, that's the problem hash tables are built to solve. Imagine, like, each book has its own secret code telling you exactly where it sits on the shelves.
A secret code, huh? All right, I'm intrigued. Break that down for me.
So it all starts with this thing called a hash function. You can think of it as a special math operation. You take any data, like a book title, and it spits out a unique number. That number, that's your book's address in our mega library.
So there's a system to it. It's not just random numbers assigned to books.
Oh, definitely not random. Our source actually uses War and Peace as an example, which I thought was pretty cool. You add up the Unicode values of each letter in the title, then divide by the total number of shelves you got. The remainder from that division, that tells you exactly which shelf War and Peace is on.
So anyone wants that book, no more wandering around lost. Run the calculation, boom, there it is. That's insanely efficient.
Exactly. And that's the beauty of hash tables. They're everywhere in computing, databases, search engines, you name it. Even
Wait, hold on. You're not about to say cryptography and blockchain are using this too, are you? Seems like a big leap from organizing books.
it might seem that way, but the core idea is the same. Finding information reliably and fast. Take SHA-256, for example. That's a cryptographic hash function, plays a huge role in digital security.
Okay, now you're going to have to refresh my memory on SHA-256. Cryptography stuff always makes my head spin a little.
It's a lot to take in, for sure. Basically, SHA-256 takes anything, digital message, file, whole document, and turns it into this unique 256-bit hash value. Think of it like a fingerprint for that data.
So even a tiny change to the original, like swapping one letter in a document, that completely changes the fingerprint.
Exactly. And that's what makes it so good for security. You can prove if data's been messed with or not. Digital signatures rely on this heavily, proving a message is really from who it says.
So it's a tamper-proof seal, basically. Now, what about blockchain? You said hash tables are in that too, right?
Oh, they're crucial. Remember how Bitcoin miners are always trying to add new blocks to the chain? That whole process, it involves solving crazy math problems that depend on hashing big time.
So it's not just storing stuff in the blockchain, it's using these hash functions to make the whole chain secure, unbreakable.
Exactly. Each block has a hash value that's linked to the one before it. Creates a record that's, well, practically impossible to mess with.
All right, I'm seeing how the secret code thing goes way beyond just libraries now. It's how we make sure digital stuff is trustworthy in the first place.
And there's more. Think about DNS, the domain name system. It translates like google.com into those number IP addresses computers use.
Oh, yeah. That saves us from memorizing a bunch of numbers every time we want to visit a website, like a giant internet phone book.
Perfect analogy. And
Yeah.
guess what? DNS is essentially a huge global hash table. Takes the domain name and instantly fetches the right IP address. That's how we browse so smoothly.
So even when I'm just online, hash tables are working in the background. Unsung heroes of the internet, I guess.
For sure. And their impact goes even further, like with search engines. Remember Google's PageRank algorithm, the one that figures out which websites are most important?
Yeah, that's what made Google blow all the other search engines out of the water back in the day. How do hash tables fit into that?
PageRank uses them like crazy to manage and analyze all the links between websites. By using hash tables to track these links and figure out how important they are, Google can quickly figure out which pages are the most authoritative and relevant for any search.
So even something as complex as Google search, it relies on this, well, kind of simple idea of hash tables. Pretty mind-blowing.
It really is. They're one of those fundamental building blocks in computer science that we don't always see, but they affect our digital world massively. They let us search, organize, secure, and access information incredibly fast and efficiently.
Okay, so we've established that hash tables are amazing for managing data. But I'm guessing there must be some hiccups, right? Like what happens when two pieces of data end up with the same secret code?
Ah, you're talking about hash collisions. It's like having two books assigned to the same shelf in our library example. Luckily, there are some clever ways to handle that.
Okay, I'm all ears. How do you deal with a digital traffic jam like that?
Well, there are a few approaches. One's called chaining. It's like attaching an extra list to each shelf. If multiple books have the same hash value, they all get added to that chain.
So like adding a little compartment to the shelf for overflow?
Exactly. Another way is open addressing. If a shelf is full, you just move to the next available one. Kind of like musical chairs, but for data. Works pretty well if your hash function spreads things out nicely.
A backup plan when things get crowded. What about those backup hash functions you mentioned? Do they come in handy here?
Absolutely. Double hashing is a technique where if the first hash function causes a collision, you use a second one, like having a spare key, just in case.
So it's all about having multiple strategies to make sure the data gets stored and retrieved quickly, even when there are some bumps in the road.
You got it. And it's an area that's constantly evolving. Researchers are always trying to make hash functions better, reduce those collisions, and make hash tables even more efficient.
I bet that's a huge challenge, especially with the insane amount of data we're dealing with these days.
It is, and it's leading researchers to explore some wild possibilities, like imagine using quantum computing to revolutionize how we think about hash tables altogether.
Okay, quantum computing. Now, that's a rabbit hole I'm definitely ready to jump into. But before we go full quantum, let's do a quick recap of what we've covered so far.
Sure. It's been quite a journey already. We started by looking at the basic idea of hash tables as a way to organize and access information efficiently. Then we explored how they're used in cryptography, blockchain technology, the domain name system, and even Google's PageRank algorithm.
It's wild to see how this secret code thing has such a huge impact on the digital world.
Yeah.
And it sounds like we're just scratching the surface of what hash tables can do.
Absolutely. The future of hash tables is filled with some seriously cool possibilities. And maybe the most intriguing of all lies in the world of quantum computing, where how we compute is being completely redefined.
All right, I'm hooked. Let's dive into this quantum world and see what's waiting for us.
So we've talked about how hash tables help us find information super fast in the digital world. But what if we could make them even faster, like crazy faster? That's where quantum computing comes in.
Okay, I'm trying to wrap my head around this. How does quantum physics change how we organize data? Sounds a bit like we're mixing science fiction with library science here.
It might sound strange, but the principles of quantum mechanics, specifically superposition and entanglement, could completely change how we handle hash collisions. You know, one of the big challenges we talked about earlier.
All right, break this down for me. How do these quantum ideas apply to something like finding a book on a shelf?
Imagine instead of looking at each shelf one by one for your book, you could somehow check all the shelves at the same time. That's kind of what a quantum computer could do using superposition.
Wait, check all shelves at once? How is that even possible?
Well, in the quantum world, particles can be in multiple states at the same time. So a quantum bit, called a qubit, can be both 0 and 1 at the same time, unlike a regular bit, which can only be one or the other. This lets quantum computers do computations in parallel, like exploring tons of possibilities simultaneously.
So, back to our library. It's like having a quantum librarian who can instantly scan every shelf for our book, no matter how many books are there. That's incredible.
You got it. Now picture that combined with entanglement, where qubits are connected, like their fates are linked. This allows for even more complex computations, potentially leading to totally new ways to deal with hash collisions.
So instead of those methods like chaining or double hashing, we could use quantum algorithms to find the data instantly, wherever it is in the hash table.
That's the idea. Quantum computing is still pretty new, but its potential to change data structures like hash tables is huge. We could see way faster searching, sorting, even changes to cryptography, all thanks to what quantum computers can do.
Thinking about all the data we're creating, especially with big data and the Internet of Things, that kind of power could be a game changer.
Absolutely. Data sets are growing so fast, traditional data management is going to struggle to keep up. Quantum computing could give us the tools we need to handle all that information.
This is exciting stuff. But I'm also wondering about the downsides. Wouldn't this much power also create new security risks? Could someone with a quantum computer just crack all our codes, like SHA-256?
That's a really important question, and researchers are definitely looking into it. The possibility of quantum computers breaking our current encryption is a serious concern. In fact, it's pushing the development of new quantum-resistant cryptography.
So it's like an arms race, with quantum computers potentially breaking codes and researchers building stronger ones to stay ahead.
You could say that. It's a super interesting and fast-moving field, affecting everything from how we keep data safe to how we make new scientific discoveries.
It's wild to think that hash tables, which started as a way to organize books, are now at the forefront of this huge tech revolution.
It really shows how powerful abstract ideas can be. Who knew that a simple secret code for data would lead to such groundbreaking stuff?
It makes you wonder what other simple ideas might be hiding future breakthroughs. Speaking of breakthroughs, are there other areas where people are pushing the limits of what hash tables can do?
For sure. One area I find really interesting is the development of better hash functions.
You've mentioned good hash functions before. Remind me why they're so important.
A good hash function is key to keeping those collisions down, making sure data is spread out nicely in the hash table, and making retrieval super fast. As we get more and more data, finding efficient and strong hash functions is getting tougher.
So it's like needing a better coding system for our library as the number of books explodes. What are researchers doing to solve this problem?
They're getting ideas from all over the place, like number theory, cryptography, and even chaos theory.
Chaos theory. That's an unexpected one. How does chaos theory help design hash functions?
Some researchers believe that adding randomness and unpredictability into how hash functions are designed could make them stronger and less likely to have collisions.
So it's like using the complexity of chaos to make hash functions more secure and efficient.
Exactly. It's a really cool area of research and shows how the search for better hash functions is pushing the limits of computer science.
Seems like no matter how far we come with hash tables, there's always something new to discover, something to improve, and even more potential to unlock. Where do you think this journey will take us?
That's the big question, and honestly, I don't think anyone knows for sure. But I do think hash tables will continue to be super important in the future of computing, especially as we enter the age of big data, AI, and quantum computing.
It's exciting, but a little scary too to think about all the possibility.
Definitely. We're on the edge of a tech revolution, and hash tables, these seemingly simple things, are right in the middle of it all.
So as we're wrapping up our deep dive into hash tables, what's the main thing you want our listeners to take away from all of this?
It really is. For me, what I'm walking away with is this. We use hash tables constantly, every day. And most of us don't even realize it. They're the silent force behind so much of what we do online.
Yeah, I'm with you there. It's one of those foundational ideas in computer science that doesn't get a lot of attention, but it's absolutely essential for how our digital world works.
And the thing is, the basic concept of a hash table, it's actually pretty straightforward, but we're pushing it to its limits, especially with quantum computing coming into play and the need to deal with just massive amounts of data.
Right, like it's constantly evolving. And for you, our listener, I think the big takeaway here is this. Understanding even a little bit about how hash tables work, it can give you a whole new appreciation for how clever and complex the tech we use every day really is.
It's like getting a peek behind the curtain.
Yeah.
Seeing the wizard working their magic, right?
Exactly. And who knows, maybe this deep dive will spark something in you. Maybe you'll be inspired to, I don't know, design your own super efficient hash function or help develop some new quantum algorithm for hash tables.
I love that. But even if you don't become, the next hash table superstar, having this knowledge means you can engage with technology in a smarter, more insightful way.
Totally. It lets you ask better questions, understand the limits of what tech can do right now, and maybe even imagine possibilities that nobody's even thought of yet.
Absolutely. Speaking of possibilities, as we're wrapping up here, I keep thinking about this. What if we could use hash tables for more than just storing and finding data? Like, what if they could help us understand the relationships and connections between different pieces of information?
Whoa, that's a cool thought. It's like a whole new level of application, using hash tables to map out, I don't know, the networks in the human brain, or how people interact in society, or even like the mysteries of the universe.
It's like using hash tables to map out not just data, but knowledge itself. The possibilities are endless.
It's mind-blowing for sure.
It is, and who knows, maybe you, our listener, will be the one to unlock those secrets.
So to everyone listening, keep exploring, keep those questions coming, and keep diving deep into the world of knowledge. Until next time, happy hashing.